Hello, game theorists. Today we're still in Chapter 4, looking at simultaneous move games. Earlier we saw some tools to find Nash Equilibria. One tool was strict dominance. Second tool was best response analysis. Now we're going to learn about tool number 3, which is called Minimax. Now this tool only works for zero-sum games. That makes it less general than best response analysis. Best response analysis worked for all kinds of simultaneous move games. Because less general, I never actually use this to solve games. If you do see a problem in a textbook that tells you to use Minimax and you decide to use best response analysis instead, I'm fine with that. So why am I introducing you to a tool that we're probably not going to use very much, if at all? The reason it is that the idea of Minimax does appear in many other contexts as well, so it's good to be exposed to it here. So let's say we have two players playing a game, and it's zero sum, so our tool is applicable. Let's say we have Megan as our row player, and Ty is our column player. So as always, row players' payoffs come first. This means that if AX happens, Megan gets positive 3, Ty gets the negative 3. So what Megan is going to do is try to maximize her minimum payoff. So if she plays A, then she thinks about what is the worst case scenario. Well, the worst thing that should happen to her if she plays A is that Ty plays X and her payoff is 3. What's Megan's worst case scenario if she picks B? Well, if Ty plays Y, she gets 1. Ty plays X, she gets -2. -2 is worse, so -2 is her worst case scenario. If Megan plays C, her worst case scenario would be -5. So her payoffs always come first because she's the row player. So she gets -5. If Ty plays Y, she gets +1 if he plays X. So then we look at the maximum of those minimums. The biggest minimum here is 3. So we're going to underline that. Now we're going to do the same thing for Ty. If Ty plays X, what is his worst case scenario? Ty is our column player, so his payoffs come second. He looks at these numbers down here. The worst of them for Ty is the -3. If Ty plays Y, what's his worst case scenario? That's the -4, because that's worse than -1 and worse than +5. So now we've found all of Ty's worst case scenarios. So what maximizes the minimum? That is, which is the best of these worst case scenarios? That would be the -3. So we give that an underline. The cell that has all the underlines is the Nash Equilibrium. So here, our Nash Equilibrium is AX. And that's how I use best response analysis. So you probably won't use it in this class because best response analysis is just more general, but the idea might be seen in some other class, so now you're familiar with it. Now, I did say earlier that it's important to write your Nash equilibrium as the strategies, not payoffs. So back in our example here, AX is right, but if you had written 3 minus 3, the payoffs, that's incorrect. So let me just give you a concrete example of why it's so important to write it out as strategies rather than payoffs. So let's say you have a game like this one. And let's try to use best response analysis to find the Nash equilibrium. So now you've seen best response analysis a couple of times already, you should have some familiarity with it. Go ahead and pause the video and try to solve this on your own. Once you're ready, press play and you'll see if you're right. Okay, I'll assume you have given this some thought. So let's say that our column player is picking X. What's our row player's best response? It's better to play A and get 0 than play B and get -1. As always, row players' payoffs always come first. Now what if Y is being played? Then in that case, it's better to play A and get 1 than play B and get 0. Now let's switch perspectives. If A is being played, what's our column player's best response? Column player's payoffs come second. It's better for them to get 0 than to get -1, so 0 gets the underline. If B is being played, then it's better to play X and get 1 than get 0 from playing Y. So Nash equilibrium here is AX. So AX is also unambiguous. The strategies are always unique. If you've written 0, 0 though, the payoffs, which you should not do, and here's why you should not do it, that could mean AX or it could also mean BY. But BY, while it uses the same payoffs, is not a Nash equilibrium. That's why I should always write the Nash equilibrium as strategies and never as payoffs. So that finishes up our tools to find Nash equilibria. Be sure to tune in for our next episode in which we'll look at applications and extensions.